Hey everybody, we're going to start lesson 1.1 on finding limits by finding limits graphically. That means that we're going to have some graph of a function and we're going to find the limit as those x values approach a specific number. Now I wanted to review real quickly some algebra and geometry skills looking at just this graph. So the first one says find f of negative 2. So that means I'm going to come over here to the x-axis and find where negative 2 is and find out what the y value is. In this case, it's positive 2. Then I'm going to come over here and the next one says f of 0. So I'm going to find an x value of 0, which happens to be on the y-axis. I'm going to find out what the y value is of that. If you notice, it's down here at negative 1. That is our y-intercept. The next one says f of 2. Now this one's going to be a little bit trickier. So if I look here at the x value of 2, you notice there's two dots. There's this closed dot right here and an open dot. Now hopefully you guys remember from your algebra and geometry days that this open dot means that it doesn't actually touch this point. This is essentially a hole. It will get infinitely close to this value at 2, but it won't actually be there. There will not be a point there. So instead I'm going to use this closed dot, which happens to be at a y value of 3. Let's see, f of 4, so I'm going to find the value of 4. Let's see, so x value of 4 is here. The y value happens to be 2. Let's try f of 6. We're going to run into a similar issue. So here's x value of 6. Come up here. There's an open dot, so we're not actually going to use that one. We're going to use the closed dot right above it, which happens to be a y value of 5. Next, we're going to try f of 8, which is over here. Y value looks like it's 1. All right. Again, this was just a review. So we were finding the value of a function at a particular point. So again, this would happen to be the point negative 2, comma 2, 0, comma negative 1. You guys get the idea. So again, we're finding the value of a function at a specific point. What I want to do now is I want to translate this algebra and geometry you guys learned a long time ago into some calculus. So here's what we're going to do now. We're going to look at the limit as x approaches negative 2 for the function f. All right, so here's what I'm going to do. I'm going to still use this pink pen, and I'm going to look as x approaches negative 2. I'm going to look at both sides. I want to look at the left side and the right side, and as long as they go to the same place, we're happy. So if I look at values around x equals negative 2, all right, so let's start at negative 3. If I watch and see what happens to this graph as it goes toward x is negative 2, it's decreasing and appears to approach this point where x is negative 2 and y is positive 2. If I look at it from the other side, if I start, let's say, at negative 1 and I go toward negative 2, I am increasing, it looks like, to the exact same point, which is, again, negative 2, comma 2. So I'm going to say this is just the best idea. Since they're both approaching positive 2, left side and right side are both approaching positive 2, that's going to be my function's value. I'm going to try something similar for as x approaches 0. So I'm going to start on the left side of the y-axis, and again, it's increasing toward this value at negative 1. Okay? And if I look at the right side, I guess I'll start at x equals 1. I'm decreasing and it approaches again, guess what? This point right here at 0, negative 1. Now, let me repeat it one more time because it's important. It has to approach the same number from both sides. So again, this is approaching negative 1 from the left and it's approaching negative 1 from the right. If I look at the next value, remember we said that one was a little bit harder because the open and closed dots. This one might end up a little bit different. So let me look at this. The limit as x approaches 2. So if I look at it from the left side of 2, let's start at 1 and head toward 2. It is increasing to this value and it's going to end up right here at this closed dot, which we said was 2, comma 3. If I look at it from the left side, I have to use, the right side, I have to use the other section of the graph. So it's increasing over here, and it's heading toward this open dot, which happens to be at 4. But here's the thing. The left side approaches 3, the right side approaches 4. Doesn't quite make sense. And so this will be one of those situations, as I mentioned in an earlier video, that does not exist. The two limits, the left side and the right side, don't match up, those two sides. Let's keep going and look at limit as x approaches 4. If I look at x approaches 4, it's decreasing on the left side toward a y value of 2. If I look at the right side, it's also decreasing. And again, it seems to be approaching this y value of 2. So we're going to write down that the limit as x approaches 4 of f of x is 2. Got two more. So limit as x approaches 6. So let's come over here and look at 6. If I look at it starting at the x value of 5, it's going up. It's increasing towards this open dot, which happens to be at 4. And if I look at it from the right side, I'm going to start here at 7. It's also increasing, and it looks like it's increasing to this closed dot, which happens to be at 5. Again, left side approaches 4, right side approaches 5. Again, we have another one that does not exist. Has to approach the same thing from both sides. I'm going to do one last one. Limit as x approaches 8. So if I look at it from the left side, we are decreasing all the way down here to this closed dot here at 8, 1. And if I look at it from the right side, we're also decreasing toward this x value, the y value 8, -1 is our point. So there we go. Limit as x approaches 8 is f of x equals 1. All right, hopefully this helps you guys understand the graphical method. Make sure that, again, you look at it from both sides. We can sometimes have these situations where one side approaches one value and the other side approaches another value, and that would be a does not exist.